My name's Tom, Zulu Romeo 6 Tango Golf, and I wanted to chat this morning quickly about SatNogs. SatNogs is a automated satellite ground station setup, which is fairly simple to build and has quite a few benefits. So what exactly is the SatNogs? So there's, because of SpaceX and a whole lot of other rocket companies that are now making it a lot easier and cheaper to send up satellites, a lot of people sending up payloads have realized that part of the infrastructure that they require is ground stations all across the world. And it's not always feasible for schools and universities and even amateur radio clubs to set up all these ground stations. So SatNogs is a solution to that. It's essentially a crowdsourced satellite ground station network. Amateurs like you and me set up these stations all over the world, and these stations listen out for the various passes over them and collect the various data. It's a fairly simple setup. So SatNogs stands for Satellite Network Open Ground Station. Like I said, it's a fully open source software and hardware project, and it's run by the Libre Space Foundation. SatNogs aims to build a globally distributed network of satellite ground stations, enabling anyone around the world to schedule, receive, and share telemetry from low Earth orbit satellites. It basically combines a shared database of satellite transmitter data and as well as a scheduling and control network. And the final piece is the ground station client software. The different hardware that you use that we'll discuss as well can range from either commercial type software or hardware and even DIY and 3D printed ones. So let's have a look of what the SatNogs systems consist of. First off, it is a SatNogs database, which is a repository where users contribute satellite transmitted information. This includes frequency, modulation, encoding, and all of it is accessible either via the web UI or via an API. Then the second part of that is the SatNogs network, which is a web application that lets users schedule observations and coordinates jobs across all registered ground stations. We'll have a look in a bit more detail on that as well. The third part of that is the SatNogs client. This is the software that actually runs inside your station on an edge device, something like a Raspberry Pi with a SDR. It essentially polls the network and gets a list of all the scheduled observations, and then it runs and executes it, decoding the data, and it uploads all the data back. And then the last part of it is obviously the hardware side. It's a fixed or steerable setup of antennas, rotator, or static mounts. And this can be built, like I said, off-the-shelf kits or using 3D printed parts. So let's first have a look at the SatNogs DB, which is essentially, it's a collection of all the different satellites that people have submitted and which should in theory be live. It's a good way to get information on whether the satellite is still alive and what's available on that satellite. Approximately at the moment, there's about 2,370 satellites listed, and there's over 4,000 transmitters cataloged at this point. And roughly around 60% of them are marked as active at the moment. If you look into a specific satellite, you can get this is the various information you can get, including the different descriptions, whether the satellite's operational, name, and an NORAD ID. It also includes all active modulations and decoding protocols. It also shows a map, which is basically, most of you will recognize this, it's the normal tracking website, which will show you where it's a live site that shows where the satellite should currently be. And then it gives you a list of all the transmitters. The transmitters panel, it basically details all the downlink and uplink information, frequency and modulation, protocol information, and then some of them even have any user contributed notes and tags. Remember, this is all a crowdsourced setup, so anybody can submit information if you find something different, or even if the transmitters and that starts to drift, you can specify all that information, and it makes it available for all. And then lastly, on the database network, or the SatNogs database, is also just a little dashboard where you can download additional information on the data that can be decoded. It also shows you all the recent observers, and it shows you, as the data frames are coming in from the various stations. So what do they do with all this data? So normally they can put it all together and have a live dashboard of the satellite data being received. So as the satellite moves around or orbits the Earth, all the different ground stations collect the various telemetry information, and with SatNogs, it basically combines it all and gives us a live dashboard. So imagine having launched your own satellite as an amateur radio club or even as a university, and now having this dashboard where all these stations receiving the data gets updated automatically and showing you all the data of your satellite. It gives you a whole bigger picture rather than just waiting for the satellite to pass over your own grade station. This basically is built with a Grafana dashboard, and it includes backend systems like InfluxDB, which power real-time visualization, signal strength, frame counts over time, decoding success rates, and even recent activity metrics. So let's have a quick diagram of how this all works. So you've got your users all across the world. The users can log into the network and schedule an observation. This is not limited to you using your own ground station. If you have an active ground station on SatNogs, then you can essentially schedule an observation on all other open stations as well. So if you know your satellite's going to go over India, for example, and you wanted to specifically get the data package from there, you can look at the different stations that are available there and schedule your own observations from there. This is a typical ground station setup. The SatNogs client runs on a computer, but it can also run on a Raspberry Pi or any Linux PC, and it essentially contacts the SatNogs network API for the different jobs that were scheduled from it. If the station has a rotator, it positions the antenna in azimuth elevation to track the satellite dynamically. If not, even a fixed antenna can be used. SDR dongle, very cheap dongles that we all play with, is usually used, and you can add an LNA on that to increase the reception of it as well. The client decodes based on protocol details and uploads all the waterfall plots, decoded frames, and metadata back to the network. So it's very simple to get started. There's easy ways and there's obviously harder ways. So the easy way is as simple as use a Raspberry Pi, a RTL SDR dongle for signal reception, and a fixed antenna like a turnstile or egg beater, or even one of the new SatPack 1 antennas that has been available from ZS6, Juliet Oscar November John. Those are all great antennas to get started with. It's a very simple setup to get going. Basically, if you've worked on a Raspberry Pi before, then it should be very familiar. But essentially, you flash your SD card with the SatNogs OS image onto the SD card, and then on SatNogs side, you basically just create an account and register your station. It will give you an API key, which you've basically used to configure on the Raspberry Pi. And then from there onwards, the client handles everything automatically. So you can schedule an observation on the SatNogs website. We usually use the NOAA weather satellites for the first observations because they're quite strong signals and easy. Although I have read that the NOAA weather satellites are being decommissioned, so you might have to look onto alternatives. Also depends, obviously, on whether you're doing a VHF or a UHF setup. Here we've got some pictures of the basic components on the easy setup. As you can see, there's not a lot required, and there's not a lot of tinkering in terms of getting your first station up and running and going. So once you've got the first one up and running and it's working well, you can obviously work on improving it. So lots of different options. Most typically, you would add a rotator and some directional antennas. Again, the hobby being the way it is, there is lots of different options. You get your commercial options, like, for example, a Yaesu G5500 or a SPID rotator that can be purchased. Or if you're more of a handy person, and as most of us amateur radio enthusiasts are, you can build your own. SatNogs provide a fully working design, reference design for a 3D printed um, rotator, which looks something like that. It's a proven design and it works quite well. And it works out a lot, cost wise, it's a lot cheaper than getting one of the commercial options. And it's a very fun project to build. So definitely can be recommended. As part of that, they've also released some designs for your different antennas that you can play with. Again, most of it's being 3D printed, the different parts combined with general hardware store parts. And you can set up a nice, impressive station that can decode pretty much most active satellites very easily. So back to the SatNogs website itself, everything is centered around observations. So an observation is something that any user on the SatWorks network can schedule, and basically means tell that station to listen out for this pass that will be coming over and collect as much data as you can. It's got all the predictions and passes shown depending on the different site locations on the website. And then you can basically log in, you schedule the observation, wait for the satellite pass. Everything will be recorded while the pass is happening. Whatever it can decode, it will decode. And then the data gets posted back to the website. Passes normally gets vetted. Basically, it means saying it's a successful pass, you can see data. It's a bad pass, there's no data whatsoever. Or it's a satellite could be a good pass, but the satellite could just not be active. So that's also a third option. We look at, that's the screen that you get, or an example screen that will show you all the different satellites for your location or for that specific station that you have selected. So you can easily select from, or easily see what times they're coming over and then schedule the observations from there. Once an observation has been made and all the data has been uploaded, you will have a screen that looks almost like this. That basically gives you the basic information. There's a waterfall view of the signals received, which would make it very clear whether there was actually any signal received or not. And then obviously there's also an audio tab, so the whole recording is recorded and you can play it back later, and also see if you want to try alternative methods of decoding the data. And there's also a data section as well. So if SatNogs clients know how to decode that specific telemetry, for example, that's a NOAA image that it was decoding there, or if it can decode it into the different hex data, then it will also show it and make it available for download. So it's a very, you can imagine now having your own satellite up there, but not having the infrastructure, that this is a very simple and easy to use system to get data from your satellite from all across the world. SatNogs is also not the only project that does this. Well, not recently, but it's been up for a while. There's a new project or a similar project called TinyGS, Tiny Ground Station. Now, Tiny Ground Station is, as the name implies, a lot more simpler ground station. It mostly covers satellites that are LoRa-based, using the LoRa protocols. And your ground station is even simpler. It consists of a small board which is usually got a ESP32 microprocessor on it, as well as a LoRa receiver. And the concept's very similar. Once it's up and running, it's less about scheduling observations, as this ground station will basically listen out for any satellites, LoRa satellites coming over its over that station's pass, basically at that point. It's even a cheaper and simpler way to get playing with this, and it's a very nice project. They've recently updated their map system, which almost shows a live view of the satellites moving, and as it receives the data, it's like pinging in the background, telling you that data has been received. So that's a very nice alternative for this. Just back to the observations, SatNogs has recently also confirmed that they've had, I think it was over more than 20 million recorded observations onto the SatNogs so far. So it's a very good way of collecting all the different information there. So yeah, to basically just conclude, it's a very easy and simple way to build your own satellite ground station. It's very minimal skills required, and you can easily put it together at a low cost. Or if you want to expand it, obviously you can throw more money at it and make a lot more complex station. It's all open, it's all freely available. All the designs from the station itself to the antennas, the software, it's all open source, and it's very simple to set up. LibreSpace is also working on various open source satellite designs as well. That's also one of their goals, is to have an open source CubeSat design that universities and clubs can use to build up from their own, or build up their own CubeSat from that proven designs. They've also launched various satellites. On that note as well, we have a look back on the TinyGS one. TinyGS also has open satellite designs, which are more LoRa-based satellites available, small mini CubeSats. So if you're in the process of looking at launching your own satellites or very interested in it, then definitely check that out. And that's basically everything you need to know about SatNogs. A very simple system to put together, collect data from all the world, and it's something that we can all get involved with. It's a lot of fun, and it definitely helps all the satellite operators as well. So it's a way to give back to everybody launching the different satellites, to help them out get their data, and we as amateur radio enthusiasts get more satellites to play with. Thank you very much.